In this lesson, we're going to focus on what this factored form of a function can tell us about the graph. And I've annotated a key point in this problem. I made this problem up specifically to study this idea. This problem is about roller coasters. Make sure you pause and read it. But we've all been on roller coasters before. And this key fact here in the text is what I underlined. It says that a height of 0 is, in this case, where the conveyor belt has to kick in. So where it starts to have to pull you back up. So I just picked that number to be important because often when we study functions, the values of x where the function is equal to 0 are important for the phenomenon that we're studying, right? So we're really going to dive into what the zeros of a polynomial function are here. In this lesson, this idea is familiar to you from Algebra 2, I think. So for question A, what I'm asking you is where is f of x equal to 0 based on the graph? And this is pretty obviously 1, 2, 3, 4 spots, right? So those 4 x values are x equals 1, it looks like, x equals 2, x equals 3, and x equals 4. Okay, and notice those numbers all already show up in my function. So this is f of x, this is the graph of f of x. So already we're starting to see maybe that there's a relationship here. Notice x equals 2 is a special point, so that's here. X equals 2 does not look like all of the other zeros here because the graph comes and touches 0 and then bounces off, right? So we get just up to 0 and then go back down instead of crossing 0, right? And notice at that point where the function touches the x-axis but does not cross it, that factor looks a little bit special compared to the rest of them too. So that's probably part of this relationship we're trying to investigate. So for part C, how do these points relate to the function? Hopefully you're thinking this already. The x-intercepts of our graph are zeros of the factors of f of x. Zeros of the factors of f of x. So as an example of what that means, right, is my x-intercept was x equals 1. So that's my x-intercept. My factor was x minus 1. So 1 was my x-intercept. X minus 1 was my factor. And when I plug in x equals 1 to x minus 1, 1 minus 1 is 0, right? So these are zeros of f of x, we would say. X minus 1 is a factor of f of x. Okay. What we're talking about here is called the factor theorem. So it's the factor theorem for polynomial function. And this is the key fact that we need here, is that for any polynomial function, if x equals a is a 0, and 0 means x-intercept of a function, then x minus a is a factor of the function. And you know this already, at the very least, from factoring quadratics. You know those factors represent the x-intercepts of the graph. So that's the factor theorem for polynomial functions. And we can add one more detail. Let's say we have x minus b squared as a factor. So that was in our example x minus 2 squared. We can say from looking at the graph that b is an x-intercept and f of x, I'm going to say that use the word bounces. I'm going to put it in quotes because like we know what it means, but like what does it mean, right? F of x bounces off the x-axis at that point, right? So what we know from a graph like this is that this x minus 2 factor will show up twice in the factorization. Okay, so that's the factor theorem. So this is the title of the lesson. So this factor theorem is important, and it's what we're going to use to solve our problems here. So this example is straight off the delta math, and what we want to see here is that if we use this fact, we can actually write a function just based on its description or based on its graph. So I'm going to draw a little sketch of f of x. So I'm going to draw a little xy plane. So sketching is always a good thing to start with. And it says my y-intercept is 90. So that'd be up here somewhere, right? So notice I'm just kind of making points. I'm not really worrying about scale or anything. And then I have zeros at -6, -3, and 1. So -6, -3, +1. And it doesn't tell me anything about like multiplicity or x squared, right? So I don't have to worry about that bouncing situation that we just talked about. This is just a basic one where I cross each axis every time I put a point. So I pretty much know I have to be up here coming down, right? And then that means I have to go down here, up here. So this is something that f of x would look like. And it says, write me a polynomial in standard form. And I actually want to show you the wrong way to do this first. So the wrong way, the smart guess would be to be like, okay, f of x is equal to x plus 6, x plus 3, x minus 1. So this is wrong. So I used all of my zeros. So that's a good guess based on the factor theorem. But notice we didn't plug in, we didn't do anything with this 90, right? And the reason I know this is wrong is f of 0 should be 90, but f of x is actually, when I plug in 0, is equal to 0 plus 6, and then 0 plus 3, and then 0 minus 1. And that gives me -18, right? 6 times 3 times -1 is -18. So this is wrong because it has the wrong y-intercept. So it doesn't match the text. So to fix that, we are actually going to do the right way. We're going to write almost the same thing, but we're going to include a value, essentially a scale factor from our transformation. So I'm going to put a in front, and then I'm going to write all of my factors, right? And now we have the same zeros. So when I plug in, for example, -6, this whole thing will be equal to 0. If I plug in 1, this whole thing will be equal to 0. But this a allows me to scale it so that my y-intercept is 90. So I know that f of 0 is 90, right? So I'm going to be like 90 equals a times 0 plus 6, 0 plus 3, 0 minus 1. And this spits out now -18 times a. And then a is going to be -5. So then I plug that in. So I get f of x is equal to -5, x plus 6, x plus 3, and x minus 1. So that is f of x with the correct y-intercept. And you could check if I plug in 0, I get 90. And if I plug in any of my x-intercepts, -6, -3, or 1, I get 0. So this function satisfies all the qualities that were given. The last step would be to rewrite in standard form. So I'm not going to do that for you in this video because you guys already know how to do that. Standard form is expanded form. So in other words, multiply it out. So what we've learned in this lesson, right, is how to take the zeros of the graph and write the function that goes with them.